particularly your data that it makes sense to average it. Okay. Quantitative data is your data that it makes sense to average it. So, you might consider this anything that is, say, averageable. You would not average, say, zip codes, but you could average miles per gallon. Okay? Average the shoe size of the class, and so on. All right. A box plot is one of the first ways that we're going to learn how to pictorially, to graphically represent a set of data. Because whenever a picture says 1,000 words, you can look at a picture and kind of learn a general trend about the data. So, there are 5 important values in a box plot that help you to summarize it. They are the minimum. Let's write these on here as we go. This is the minimum here. Q1 is this value here at the left part of the box. The median is this one here. Now, notice, you know what median is. You've computed medians before. How do you get the median? Put them in order and find the one that's in the middle. So, it's interesting to note that I purposefully did not place this median here smack dab in the middle of the box. And it is correct. I'll explain to you why that is in a different place later. So here we go. Next, this is the Q3. And then up here is going to be your max. So those are the 5 numbers that make up the box plot. All right. Now, when you have this box plot, these items, these sections are called quartiles. And the reason that they are called quartiles is because it divides this up into sections, and 25% of the data is in this first quartile. So if you have 20 numbers, 5 of them are in the first quartile. You have, then 5 are in this second quartile. 5 are in this third, so 5 of the numbers are here. And 5 of the numbers are here. So these are quartiles because 1/4 of the numbers are in those places. Now that brings me to why this section of the box plot is a different size than this section. And that would have to do with the numbers that are in there. If I have 5 numbers inside this part and they range from, say, 20 to 25, okay, then this is going to be a larger span of values than if, say, Q3 ends up being the number 27. This is only 2y. And those 5 numbers span 5 values. So, here you're probably going to have some decimals or you're going to have some repeats. And so they're all within 2 points of each other. Okay. And finally, the anatomy of this box plot really focuses on this middle section. This middle 50% tells you a lot about the quality of the data. We're really interested in how varied that is. This middle 50% is called the inner quartile range. Yeah, I know, sorry. I'm having trouble with that word inner because I even did it wrong on the simulator. Inner quartile range. That is always referred to as IQR. People usually don't say, find the inner quartile range. That's because it's longer. They'll typically say, find the IQR. Okay. The way that you find the IQR, it's the range. It's the distance from Q1 to Q3. It's the distance from Q1 up to Q3. So to find that value, you go Q3 minus Q1, and that'll tell you how far apart they are spread. Now, just a little typo I saw this morning and kind of annoyed me. I found it after I copied off the papers. This is the inner, as in the inside, not the inter. So there's a little N you got to fix there and there. So sorry, brain dead when I was doing that. Okay? to understand a box plot is talk about the outliers. But I want to come back to this in just a second. I want you to turn your paper, and I want to start making a box plot. So here's your data. This is having to do with the cargo volume of something. These are 15 numbers. They're not two separate sets of data. So this is like one complete set of data. So what's the first thing that you have to do whenever you want to do things like median and such? Okay, put them in order. So let's do that. Let's put these 15 numbers in order. Order up. So 56.5 is the smallest value. There is another 56.5, so you list it twice. Next is 57, and then so on. So take a second, write those down, and we'll check them here in a minute. Okay, so there's your order for 15 items. I ran out of room, so I had to go down the side of the page. Okay, since your data is summarized with the 5-number summary, those are the numbers that you want to identify first. Okay, so you need to know what the things are in a 5-number summary. Do you remember from the front page? Think of them in order from left to right. The first number is the minimum, and then Q1, and then median, Q3, and then maximum. So those are the 5 numbers you are going to find right now. So here we go. Minimum, which is 56.5. I'll tell you how to find Q1 in a second. We'll compute median in a moment, as well as Q3. The maximum is 103.5. So, median, you've experienced computing before. So let's do that. Now you can use your brain and say, there's 15 problems or 15 numbers. I'm going to divide by 2. That's going to put that median at the 8th value, which is this 73.5. Okay, I do want to show you that because this kind of visual concept will help in something that we will do in the future. I want you to understand that to get to the center, really what you're doing is you're knocking off the bottom and knocking off the top. Knocking off the bottom and knocking off the top. And knocking off the bottom and knocking off the top. And so on and so on. Now, I realize that this is kind of a baby way of doing this, but later when we get into histograms, there will be a connection between the finding the median and being in the histogram that I kind of want you to understand that value. Okay, so our median is 73.5. Now, Q1 is the middle of this bottom half. Q1 is the middle of this bottom half. So let's find the quote-unquote median of the bottom half. Here it goes. I'm going to do that in a different color. So I'm going to take this bottom half. Some texts include the median in both sides when they compute. Some don't even count the median, and we're going to do that. Some just leave the median as the median. That's what we're going to do. So, bottom is 56.5, 67. Bottom and top. Lowest number, highest number. So 58.5 is that middle of the bottom half of values. Do the same thing for the top. Bottom and top. Bottom and top. And so there we go, 75.5. Okay, those have been identified. We are going to also need the inner quartile range whenever we talk about outliers, so we'll get that in a minute. But do you remember how do you get the IQR? Q3 minus Q1. You want to go ahead and do that right now? Q3 minus Q1 is the IQR, the inner quartile range, which, if I subtract Q3 minus Q1, we get 17. We'll come back to that. So that means the middle 50% of data is spread 17 points apart. Let's now start graphing. The important thing to note is that you want these drawn to scale. And since you want these drawn to scale, you are going to start with a number line that sufficiently spans the value of your data set. So we're going to do that. Our values go from about 55 to about 105. So draw yourself a line. And I'm going to go by fives. I'm going to put the box under it. So do your number line. Okay. There is our, that's going to help us get our values drawn to scale. So if something is smaller than something else, you will be able to tell that by the size of it. The area principle will not be violated. All right, so the next step, I really would start with the middle. Let's place the values of the box. So the median and then the Q1 and Q3. So there we go. Our median is 73.5. That's probably about right here. Do not place this on top of your number line. You're going to have too much stuff going on. So let's draw this above or below your number line, not on top of it. Okay, Q1 was at 58.5. By the way, I'm numbering these 73.5, 58.5. That is a span of 15. Those three values in that part of the box span 15 numbers, 15 numerical values. That's not the whole thing, that's the left half of it. Now the Q3 is 75.5. So now that's the box. Inside there is half of the data. Okay. Okay. So there is our stuff there. And now we want to address the whiskers to see how far the rest of the data spans. There's an issue, though, of drawing your whiskers. We need to identify outliers. So that's the next thing. If you turn to the front, I kind of skipped going over this. There are mathematical rules for the outliers on box plots. So they actually have a mathematical rule. There's this thing called a lower outlier fence. So let's think about this and kind of give you an idea of what's happening. There's this imaginary lower fence, and if you have data that goes on the other side of that lower fence, those are called lower outliers. You also have an upper fence, an imaginary upper fence, which we're going to find out and numerically calculate where that is. And if you have a piece of data on the other side of that, on the right side over here, then you have an upper outlier. If you do not, then you do not have an upper outlier. Okay? So let's figure out how to compute those fences. Here's how it works. The lower outlier takes Q1 and it subtracts away. So, correct. So this is Q1 minus 1.5 of the IQRs. That's how you get that line. Let's do that on this. So here we go. Let's find our lower outlier fence. 1 was 58.5. 58.5 minus 1.5. We already computed the IQR a minute ago, and that was 17. So when I get that value, that is 33. So the outlier fence is at 33, and anything below that is going to be an outlier. So let's look at where that is. Does that even appear on my whiteboard? No, it's like way over here towards my desk. Some little imaginary line over here at 33, and if there's something to the left of it, it's a lower outlier, but we have none in this data. So we can go ahead and draw our whisker to the lowest point, which was 56.5, and there's our lower whisker. Okay. Now we want to see if there is an upper outlier. So we need to find the upper outlier fence. So by the way, there were no lower outliers. Okay, so here we go with the upper fence. The upper fence is going to go from Q3. So that's going to be Q3 plus 1.5 IQRs. And that will give you this fence. Here we go. Upper fence is Q3 plus 1.5 IQRs. So those values are 75.5 plus 1.5 times 17. That gives you a fence at 101. So we do draw that on here, right here. Here is our 101 imaginary outlier fence. Do we have a value in our data set larger than that? Yes, we do. It is this one, 103.5. Anything to the right of the outlier fence, of course, is an outlier, and it is notated with a point, and then say what that value is, 103.5. Now, you draw your whisker. Do not draw the whisker to the outlier fence. You draw it to the next lowest number inside the fence. So in your data, what's the next lowest number inside the fence? This right here, 98, okay? So I go and I put a mark at 98. That's how far my whisker goes out. If you had more than one outlier, you would draw more than one outlier, and you would label them. Okay, but we did not in this case. So that is how a box plot is made from its basic form. It gives you an idea of the spread. It gives you an idea of how far things are apart from each other. And so then your homework is to do that process for two problems. There's one on the front and one on the back. And so you have to know the rules and the labels of these items.